The Earth isn't flat. This is called gravity. I'm Neil deGrasse Tyson, bitch. You know, from television.
An open letter to Neil deGrasse Tyson. Dear Mr. Tyson, I am writing to you as a former man of science that once looked up to you as an inspiring figure in a field with very few charismatic black people. You could say I was a fan. I visited the Hayden Planetarium, I watched all your lectures and television appearances, and I was struck by your ability to explain complex topics in cosmology and astrophysics in simple, concrete terms. However, your recent responses to queries regarding the flat Earth can only be categorized as arrogant, childish, and sneering.
The Earth isn't flat.
I mean, dropping a microphone somehow proves gravity.
This is called gravity.
Also, asking
At what point do you stop arguing things that have been settled for 4 centuries?
Seems ridiculous to me, since nothing in science is ever settled. Everything in science exists as a theory that only stands until a better theory comes along that more closely matches observations. Would you have told Einstein not to bother because Newton had already settled that gravity business 200 years earlier? I'm sorry, sir, but you're going to have to do much better than that. The resurgence of the flat Earth is not merely a handful of tinfoil hat-wearing crazies who lack intelligence and teeth. This is a shift in consciousness by ordinary people who have started to re-examine the lies they were told as a child. Your job, sir, is to respectfully answer legitimate questions whether or not the answer supports the scientific model that you are a proponent of. Traditionally, scientific progress has not solely come out of the scientific community, but from ordinary people with a different point of view. The scientific method demands that you treat each point of view with respect, as it has the potential to overturn the existing model. And if science refuses to even entertain alternative views, then it is no longer science, but a religion of scientism. So, I would like to ask you 12 questions and give you the opportunity to answer them respectfully, using simple, easy to understand concrete terms that you are so famous for. Because I'm just an ordinary bloke, nowhere near as smart as you are. So, if you could give your answers using real, tangible terms without complex mathematics, abstract concepts, or references to NASA or other data that I have no way of verifying for myself, I'd appreciate it. Question 1. Why is there land at the equator? So, you said that the Earth
throughout its life, even when it formed, it was spinning, and it got a little wider at the equator than it does at the poles. So it's not actually a sphere, it's oblate. And officially
it's an oblate spheroid, and the bulges are at the equator. So which is easier to move, rock or water? If the gravity is strong enough to prevent the water from being flung off into space, then it's strong enough to hold the much denser rock in place, so only the water should be bulging. So if the bulk of the Earth's water is at the equator, why is there land at the equator? And please don't say it's because of the height of the land. Most of Africa is flat plain, sometimes under sea level. In fact, the Danakil Desert in northeast Ethiopia is said to be the lowest place on Earth, and incidentally one of the flattest places on Earth too. Question 2. Am I able to see the curvature or not? According to you, you cannot see the curvature even from a plane because the Earth is so big.
The Earth looks flat because 1, you're not far enough away at your size. 2, your size isn't large enough relative to Earth to notice any curvature at all. It's a fundamental fact of calculus and non-Euclidean geometry. Small sections of large curved surfaces will always look flat to little creatures that crawl upon it.
But apparently you can see ships disappear over the horizon. Now, the official explanation is that you cannot see the curvature across your vision. Apparently we see a horizon about 5 miles away. So in 5 miles there's enough curvature to see a ship disappear. Yet I cannot detect that curve over 10 miles because I can see 5 miles to my left and 5 miles to my right, so I've got an uninterrupted 10-mile span in which I should see enough curve to hide 2 ships. But I don't. So if I see enough curve over 5 miles, why don't I see it over 10 miles? Following on for that, question 3, why haven't we ever seen curved water? If the Earth bends the water into a sphere around it, then if it was to freeze suddenly, we should detect a hump in the water, shouldn't we? So why is it that when Lake Baikal in Siberia freezes over, it is one of the flattest places on Earth, despite being 395 miles long and 49 miles wide? There should be a hump in the middle of it, nearly 20 miles high. So why haven't we ever seen curved water? Question 4. How are we breathing right now? How can there be a high pressure system next to a low or negative pressure system without movement from high to low? So the conventional answer is that gravity holds the air to the Earth. But if I was to evacuate a container to a fraction of the perfect vacuum of space, turn it upside down and puncture the bottom, what do you think would happen? Well, the air would rush in and fill the container. So, how does this much weaker vacuum manage to overcome the much stronger gravity near the surface? How is it that you can heat the air and it will rise against the force of gravity? Wouldn't the air leave the Earth once the sun heats the air? If gravity is the only thing holding the air to the surface of the Earth against the tendency of a high pressure system to escape to a low or negative pressure system, then when the air is heated and so is less affected by a gravitational pull, shouldn't it then succumb to the force exerted towards a region of negative pressure? If, as current scientific opinion suggests, a high pressure system can exist adjacent to a negative pressure system, then there should be a boundary condition of equilibrium where the force towards pressure equalization equals the opposing force of gravity. Thus, any change to the conditions on either side should disturb the equilibrium. Wouldn't a rising column of warm air disturb that boundary layer? So, how are we breathing right now? Question 5. Is the Earth very, very small, or is the Sun very, very near? Eratosthenes' calculation of the Earth's circumference is dependent on the light from the Sun being parallel, as it should be if the Sun is 93 million miles away. But anyone can go out on a sunny day with broken cloud and see that the light that arrives on the Earth is not parallel. The light rays come down at angles, indicating that the Sun is actually very close. Now, the official explanation is that the Earth's atmosphere refracts the Sun's light, and that's why the light comes down at diverging angles. So, if the light from the Sun is always refracted, then that would mean that Eratosthenes' calculation was made with refracted light, and therefore must be wrong, and the Earth must be much, much smaller. So which is it? It seems to me that if you still claim that Eratosthenes' calculations are correct, then the light cannot be refracted. But if the light is not refracted, then the Sun is close. And if the Sun is close, then for Eratosthenes to observe what he did, the Earth must necessarily be flat. Question 6. In a similar vein, how does a convex lens make light diverge? So again, the official explanation for diverging sun rays is that the Earth's atmosphere refracts the Sun's light like a lens. But the Earth's atmosphere is apparently a convex curve. So that would act like a convex lens and converge the light, concentrate it like a magnifying glass. You'd need a concave lens to make light diverge as we observe. Now, some have said that it is actually the angles between layers of clouds that seem to make the light diverge. But again, observation says that this is not the case. Here, there is nothing between the plane and the cloud, and the light is clearly diverging. And this NASA photograph is taken from above the clouds. And still, the sun's proximity is apparent. So, how does the atmosphere make light diverge? Question 7. Why doesn't the artificial horizon on a plane roll backwards during straight and level flight? The artificial horizon is based on a gyroscope, and when a gyroscope spins, it resists movement away from the axis of spin.
As for rigidity in space, the spinning rotor remains in its original attitude, while the gimbals and base move around it. In other words, the gyro maintains its axis in relation to space and not to the surface of the Earth. If a gyro moves around the Earth, its axis is vertical to the Earth's surface here, at an angle here, and horizontal here. The gyro will resist any force that attempts to change its plane of rotation.
So the artificial horizon is essentially a gyroscope mounted on gimbals to allow it to stay upright as the plane pitches and rolls. So as the plane flies straight and level and rounds the curvature of the Earth, the gyroscope in the artificial horizon will remain upright with respect to where it was first spun up to speed, and the indicator will appear to roll backwards and indicate a climb. Now, I asked the pilots of the last flight I was on, and they told me that the artificial horizon has GPS and sophisticated electronics that adjust the indicator depending on where they are on Earth. But when I contacted a manufacturer, I was told that it is a purely mechanical device. No GPS, no electronics, and it hasn't changed in basic design since before the advent of electronics. So, why doesn't the artificial horizon roll backwards as they round the curvature of the Earth? Question 8. Why is the Coriolis effect so selective? This is an explanation of the Coriolis effect by a gun expert.
One of the common issues that we see is the Coriolis effect. And what guys are not doing is taking into account the effect that this can have on your shooting at longer ranges. Now, real quick, let's kind of just explain the Coriolis effect in layman's terms. The Coriolis effect is the effect that when the bullet leaves the barrel of the gun, it is actually leaving the surface of the Earth. So as the bullet leaves the barrel of the gun, the Earth is still rotating, and the bullet is not rotating with the Earth. So the Earth will actually rotate out from underneath of the bullet while it is in flight.
So bullets and artillery shells no longer rotate with the Earth when they leave the surface. And according to this explanation, paper aeroplanes act in the same way.
So imagine you were standing in Texas and had a magic paper airplane that could travel hundreds of miles. If you threw your airplane directly northward, you might think it would land straight north, maybe somewhere in Nebraska. But Texas is actually spinning around Earth's axis faster than Nebraska is, because it's closer to the equator. That means that the paper airplane is spinning faster as well, and when you throw it, that spinning momentum is conserved. So if you threw your paper airplane in a straight line toward the north, it would land somewhere to the right of Nebraska, maybe in Delaware. So from your point of view in Texas, the plane would have taken a curved path to the right.
If this is the case for bullets, artillery shells and paper airplanes, then why is it not the same for real aeroplanes? Airplanes do not aim north to go east. In fact, if aircraft no longer rotate with the Earth when they leave the surface, then east to west flights should take much longer than west to east flights. And landing on a moving runway would seem to be quite tricky. Every landing should be like this. And wouldn't there be planetary direction indicators by runways, just like there are wind direction indicators? So why is the Coriolis effect so selective? Question 9. What is the International Space Station flying over? Whatever it is, it kind of looks a bit like what I imagine the Earth to look like, but it can't be. If you choose a feature on this blue and white thing and follow it, you'll notice its speed towards the camera is constant. From the moment it appears on the horizon, it moves at the same speed until it disappears below the camera. But watch this footage from a plane. When something appears on the horizon, it moves slowly, but the closer it gets, the faster it moves. In just the same way that we see distant things move towards us in real life. Now look again at this thing. Everything is moving at the same constant speed. Now that tells me that what we're looking at does not span thousands of miles, but rather hundreds of yards. So what is it that the ISS is flying over? And while we're on the subject of the ISS, question 10. How can microgravity be selective? Watch these people bobbing around in microgravity.
Tonight our Earth will have completed another orbit around the Sun, and now we take stock of what we accomplished over the past year and what we hope to accomplish in the year ahead.
As we look back at the achievements of the past year, 2008 was the year when the space station...
Did you notice the problem? Watch it again.
As we look back at the achievements of the past year, 2008
Did you see the water
was the
drip
year
in the background? In this sequence, I want you to keep your eye on the ketchup bottle once it's placed on the table. Right here you can see that there is nothing on the bottom of the bottle, no Velcro or magnets, it's just an ordinary bottle. And in a moment you'll see the ketchup bottle being placed on the table. Now keep your eye on it. See how it rocked when he nudged it? And again. And again. And again. It's clearly under the influence of so-called gravity. How can microgravity be selective? Question 11. Why are there craters on the Moon? If the Moon used to be much closer to the Earth, slowly moving away from us, and is tidally locked to the Earth so that only one side is ever visible, then why are there impact craters on the one side of the Moon that is protected by the Earth? I am guessing that you'll repeat the same story that the Moon's gravity has been protecting the Earth by hoovering up meteors and asteroids, but shouldn't the Earth's much larger gravitational field have been gathering up these meteors and asteroids and protecting the Moon? So how are comets, meteors and asteroids able to pass through the Earth or avoid the Earth's gravity to be able to hit the face of the Moon that's shielded by the Earth? And finally, question number 12. Why don't you find permanent hills, mountains and valleys in the ocean? The Earth is not a smooth ball, nor is it perfectly spherical. there are huge geological features such as the Mariana Trench and undersea mountain ranges. In fact, by some accounts, the Earth without the oceans actually looks like this. We observe water behaving like this, and like this, but you say it behaves like this. So why doesn't it behave like this? If the oceans are pulled to the Earth by gravity, and the strength of that gravity varies with the distance from the centre of the Earth, then why doesn't the water follow the shape of the seabed? Now, Mr. Tyson, these are legitimate questions posed to you in all seriousness. I think the questions are simple and straightforward, and I've clarified them for you. So I'd appreciate clear, straightforward answers. I'm emailing you these questions, posting them on your Facebook page and YouTube channel, as well as a few other avenues. So, in the words of Douglas Adams, if you manage not to respond, I'll know that you're trying not to. I'll know that you're trying very, very hard indeed. Yours sincerely, Allegedly Dave, England. Charismatic black people. You could say I was a fan. I visited the Hayden Planetarium, I watched all your lectures and television appearances, and I was struck by your ability to explain complex topics in cosmology and astrophysics in simple, concrete terms. However, your recent responses to queries regarding the flat Earth can only be categorized. The flat Earth is not merely a handful of tinfoil hat-wearing crazies who lack intelligence and teeth. This is a shift in consciousness by ordinary people who have started to re-examine the lies they were told as a child. Your job, sir, is to respectfully answer legitimate questions whether or not the answer supports the scientific model that you are a proponent of.
The Earth isn't flat. This is called gravity. I'm Neil deGrasse Tyson, bitch. You know, from television.
An open letter to Neil deGrasse Tyson. Dear Mr. Tyson, I am writing to you as a former man of science that once looked up to you as an inspiring figure in a field with very few categorized as arrogant, childish and sneering.
The Earth isn't flat.
I mean, dropping a microphone somehow proves gravity?
This is called gravity.
Also, asking
At what point do you stop arguing things that have been settled for 4 centuries?
Seems ridiculous to me, since nothing in science is ever settled. Everything in science exists as a theory that only stands until a better theory comes along that more closely matches observations. Would you have told Einstein not to bother because Newton had already settled that gravity business 200 years earlier? I'm sorry, sir, but you're going to have to do much better than that. The resurgence of